So we have covered the initial period where certain proteins got together and made the first cell that is everyone's ancestor. And then just millions of years down the line, some of the single cell organisms started to band together in a kind of a symbiotic relationship and form multicellular organisms. How did that all come about? And then there was a period called the Great Oxygenation Event. So what is that, and how did we reach there as well?
We don't really know how the first life came into being. It's a question that I don't know. Some people it might sound a bit pessimistic that we might never find an answer, because, like as I said before, it happened incredibly long ago, and we can't recreate the exact environment again. But there are many theories that can actually explain to some extent how it might have happened. So the first life was very simple. It was not definitely a first cell. A first cell, when the most popular misconception is when people say the first simple cell. So, but the thing is, like, if you just look into a cell, the machinery over there is absolutely amazing. So it's really complex. So when we say the first life form is the first self-replicating molecule, it could have been a primitive RNA, a ribonucleic acid. And then it started making copies of its own, and then it actually found itself in a small chamber where it can actually be safe from the extended environment. There are many places, many theories that says where the first life could have originated. Some people, the most plausible one is the black smokers, where you just go deep down in the ocean, you can actually see the hydrothermal vents. So these actually create, it's a very hostile environment, it's very hot, it's very acidic and alkaline. And but the thing is, like, there are small pores. So some people actually, if you, there's an excellent book on this one called by Nick Lane. Some people argue that there is a small cavities in these black smokers that can actually create a specific environment for cells to form. So basically, these small cavities could have served as the first cell wall where the first self-replicating molecule found its way. And then like a lot of evolutions took over the moment the first cell or the first molecule started self-replicating, made mistakes, and then it formed. It took a lot of time, took millions of years probably to become a first unicellular simple cell.
Yeah, sorry, I don't mean to interrupt you. I just had a question here as well. I read somewhere that the mitochondria itself was a separate
Absolutely,
organism, and
absolutely
that merged with the cell, and that's
true.
when it.
That's very fascinating. I mean, like, so until recently, in 50s and 60s, people started looking into. So basically, when we think about evolution, so evolution is like when we have a variation, nature selects it from. So the thing is, like, people think mutations are the only sort of variation. So if you want a mutation to happen, if you want extra genetic material, you have to. There are jumping genes. There are genes that, like, take small pieces from your own genome and, like, push it here, change genetic switches and other things. But we also now know that, like, we also started taking genes from other organisms itself. So what happens is, like, when you look at chloroplasts in plants, and if you take mitochondria, they look like, superficially, if you, the cell organelle itself looks like a separate cell. It kind of divides into in fission, like it kind of breaks away into two small pieces. It reproduces, but the thing is, like, it also has a separate nuclear DNA. It has its own DNA. It has its own genome. So when people started comparing all these ones, the human mitochondrial DNA, the genome, is closely related to a bacteria than to humans. The chloroplast. So basically, looking at all these ones, so several million years ago, there was a bacteria. There was one more bacteria that it sort of engulfed. And the thing is, like, instead of digesting it totally, it started putting itself to work. It's more like, I eat you. Now, all your job, I'm going to give you protection. I'm going to just, like, help you survive. All you have to do is, like, produce energy so I can actually run my own machinery. So it's more like we put these little bacteria to work. So it didn't happen once, it happened many times. So this is like it's a symbiotic relationship. So all the mitochondria in our, so mitochondria is the power cell. So it is the power currency. It is how what's fueling our cell. So the chloroplast in plants and the mitochondria in our body did come from a different bacteria.
Oh, that's fascinating. You did mention about how we will never find out about the origin of life. There's a theory that's called panspermia, which is that life actually emerged on one of those asteroids or meteoroids, and when it crashed into Earth, that's when it landed the microbes here. Is that something you look into much?
Well, I mean, like it is also plausible. Like, but the thing is, like, it's not answering the question. I mean, like, the question is like, how did life came into being? How the origin happened. But the thing is, like, when you say like it came from space, but it's more like you're pushing the question to an asteroid. I mean, like I can always come back and say like, how did that life begin? So it is in my opinion, it's not answering the question, but it's trying to just like, push it away from us so that it doesn't look very daunting. But I personally believe life evolved separately. It's still evolving like separately in different parts of the universe, but it did happen here on Earth with all the climatic conditions and everything. It did origin like panspermia. Yeah, it could have been possible, but evidences point out that like it formed here.